Good morning, everyone. Okay, so does anyone have any questions or concerns for me before I get started with the material that I'm going to cover? Okay, so let's get started with just a simple reminder of upcoming events. Okay, so what you see there, just want to keep reminding you that this is why you should have this printed and in your notebook for every class that you take. Just wanted to remind you the test for Unit 1 opens on 9/17 at 6:35 p.m. and closes on 9/20. At the latest, by 9:20 at midnight, that's the closing time for everything, 11:59 p.m., all the portfolios for Unit 1 are due, and that would be Portfolio 1.2, 1.4, and 1.5. So yes, in answer to some comments that have been made, oh, there's additional tabs on the template, the portfolio template. And that is true because sometimes we actually assign more portfolios than what I have assigned you this semester. So we like to have that information ready and accessible to the students. However, when you look at the drop boxes, you'll see that the title of the Dropbox, where you're actually going to turn in your saved template, says the due date, and it says 1.2, 1.4, and 1.5. Furthermore, there are only videos for 1.2, 1.4, and 1.5. So just a little clarification on that. Okay. So if you have any questions, please just interject so I can address them. All right, let me take roll real quick. I'm going to make all of you presenters because when you're a presenter, you can share your work, a picture of your work. And by the way, if you ever did want to show a picture, you'd have to snap a picture of it or create a PDF of your file and save it to your desktop. That's what I would do. That's why you should get very familiar with using a scanning app, because when you scan something using a scanning app, which is what you're going to have to do when you take a test anyway, you're going to have to scan all your work and turn it into a Dropbox that I've prepared for you. I'll go over where those Dropboxes are again every time you take a test. And when you do a class activity, as you're going to do today, you have to make a scanned version, a PDF version with a scanning app, and drop it off to the Dropbox, because the Dropbox will only accept PDF files and a couple of other files that are comparable to PDF files. So we might as well get used to doing that. So anyway, if you were in let's say you were doing an activity and you wanted to share with the other people in your group, I'm going to try and put you in groups again today, see if we can get that to work. When you want to share a picture, you can just use your scanning app, snap a picture, save it, and then save it to your, you could send it to your email and then save it to your desktop, or just send it directly to your desktop, and then you can show all the people in your group. You can also use the whiteboard when I make you a presenter. So right now I'm going to take a couple of seconds and I'm going to take roll and also make each of you a presenter. So hold on for 1 second. Okay. Okay, so that's everybody that's in here so far. And let me put that to the side. Okay, so the next thing that we're going to go over is you're always going to see me spiraling back to other sections that I've taught just so we can keep that content fresh in your mind. Welcome, Arturo. Let me make you a presenter. Okay, so we're going to spiral back to page 48 in your book. So if you have your book, hopefully you have it at this time. We're going to go to page 48 and we're going to do numbers 3 and 4. Welcome, Carlos. Let me just finish taking roll. Okay, Arturo, if you can't sign on to Blackboard, that's a good thing to bring up. I have heard discussions amongst the other teachers that some of their students have had troubles lately signing on to Blackboard. So let me just make this comment. When you go to the IRSC main page where there's a male student there working on his computer, you can either use what's called quick links. I mean, I like to use that because then I don't have to go in, I don't have to worry about signing in and using my password and all that stuff. Or you can use Pioneer Portal. If you are having trouble signing into Blackboard, don't use quick links. Go in through your Pioneer Portal where yes, you will have to know your sign-in credentials, but hopefully you do because you do almost everything through Pioneer Portal, like register. And then you can get in that way, okay? So I just wanted to make that comment. So Arturo, thank you for bringing that up because I've been meaning to talk about that. Presenter. Okay. So as I said, we're going to go to page 48 in the book. We're going to talk about some concepts that were in previous sections. Let me just share my screen with you because I want to show those of you who don't have the book yet where you can look at the book pages. Okay, so let's see. Okay, so here is your Blackboard shell. So if you're trying to look at the book, you can get it right in Alex by pressing the Alex link, coming over here to where you get into Alex. Notice that I put a tech support number there for those of you that might run into some kind of problem. Let me go into student view, which is the way your page appears to you when you're in Alex. And if you wanted to pull up certain pages in the book, let's just get out of there. You can go right here to the menu button. These three crosshairs look like a little hamburger bun and hamburger. So go to the textbook, go to the ebook. And if you were going to go to page 48, that's part of section 1.4. So you would just go Unit 1 sections, use this pull down menu, go to section 1.4, and then go to the page that you want to go to. See, there's the pages off to the left. See, this is what I'm going to be working on right here, compound interest, but in order for me to work these problems, I have to switch over to the camera. So I'm just trying to show those of you that don't have your book yet, where to go and how to pull up the ebook. Okay, let's get out of there. Okay, now I'm going to share my camera. Okay, so here is page 48. Let me make this bigger. Yeah, and one other thing I wanted to say to you is when you do sign into the session for today, it automatically takes attendance, even though I am creating a backup copy of the attendance. But if you're inactive or leave the session, like within 5 or 10 minutes, it makes note of that and marks you absent. So just putting that out there for those of you that are aware of your participation grade, the 5%, which has to do with attending and doing activities. Okay, so here we go. Going back to page 48, this is problem number 3. I wanted to review this because it sometimes trips students up. Not so much simple interest, but more like the next table, which is on compound interest. So I just wanted to do some of that again. Okay, so they give you the information above. They say in account 1, this first table that we're filling out is with regard to account 1. You're depositing $1,000 actually in both accounts, 5% interest on both accounts. And in this first table, you're doing simple interest. So with simple interest, because the formula is principal times rate times time, that just gives you the interest. But if you want to know the final amount in your account, then you would have to add the interest to what you had when you started. Simple interest, I wanted you to understand that it is like a job where you have the same exact salary every year. You never get an increase in what you're being paid. And interest is an amount of money that you are actually being paid. So once you figure out what you're going to get paid the first month as an interest amount, you continue to get that amount every year. So that means you have choices for calculating these answers. You can either just do repeated addition, which is the same thing as multiplication, or you can flat out use the formula. Okay, so I'm going to be using the formula, but keep those comments in mind. So I'm going to do the interest first, then the final amount. That is the way this formula works. Okay, so I don't want to write on my book page, so let me just put it down here. First year, second year, third year. Okay, so then for interest for the first year, I'll put a little subscript here of 1, meaning after the first year, the interest would be P times R times T. There's the formula right there. P is principal, so that's the amount you walk into the account with. The rate is 5%, but you may not use it as just a 5. It has to be in decimal form. And in section 1.1, we talked about when you want to change a percent into a decimal. Like right now, you don't see the decimal, which means it's all the way to the right of the number. You have to move it 2 places to the left to convert it into a decimal. And the amount of time we're talking about after 1 year. So when you put this into your calculator, 1,000 times 0.05, you see that you have earned $50 interest on the first year. So that would be the answer that goes right in here. If you want to fill in the second column, which is for the final amount, it'll be interest plus your principal. So the interest was $50. plus the principal, which puts you at $1,050. Okay, then, as I said, you're getting the same amount every year. That can kind of cut down your work. So, interest for the second year, without you even calculating it, is going to be $50. And it says, it doesn't say how much total interest, it says how much interest will you earn in the second year. So just another $50. However, when you go to figure out what final amount in your account after 2 years, it's going to be this extra 50 that you just earned in the second year, plus the amount that was in your account as of the end of the first year. So 1,050. And this little magic thing that I'm doing over here is called showing your work. Make sure you get used to that, because some students try to turn in a test where they don't have the steps to back up the answer, and then they say, I just did that in my head, or I just did it in my calculator. Not good enough. If you're going to take a college class, you have to learn how to document your work. So even if it's addition, or even if it's something you're going to press into the calculator like this, you need to write it down and then give the final answer that your calculator assisted you with. Moving on to third year. You earn again another $50, so that on the third year, it is a new $50 that you earn during the third year, plus what you had as of the end of year 2. So that would be $1,100, which now gives you $1,150. Okay, if you want to know what's going on during the 20th year, now because you've skyrocketed into the 20th year, you could either go 50 times 20 if you want to, but even if you put it in this formula right here, 1,000 times 0.05 times 20, I'll do it that way, you're still going to get the same answer. It'll be $50 that you earned on the first year times 20. So I'll just go ahead and put it in the formula. So it's initial principal. Principal means your initial amount. Then it's 0.05, but the amount of years would be 20. If you're just skipping from one year to the next year to the next year, and these years are consecutive, in other words, only a space of 1 year in between them, you can just add an additional 50 each time. But if you're going to skyrocket to sometime in the future, then maybe you want to use the formula, or you could use multiplication. Just $50 times 20 will give you this same answer. So in the 20th year, get my calculator, it's going to be 50 times 20, which is another $1,000. So the only problem with that is that, let's see, final amount. Would be the $1,000 you had at the beginning plus the $1,000 that you have. You can't just add on to this amount right here. So it'll be, I'm going to go back to the 1,000 I had originally plus the 1,000 that I have earned over the course of 20 years, bringing me up to $2,000. Okay, I also wanted to re-demonstrate for you the compound interest formula. Okay, so that's number 4 right here. New formula, which means that you have to know how to use your power key. This is what we call an exponential function. So you see that there's an exponent right there. That's the same thing as a power. Another thing I wanted to comment about, this will be something that I actually show you a diagram of when I give you the notes for lesson 1.5, is that because the amount that you were getting every single year when I did simple interest was the same amount over and over and over again, if you were going to try and do a graph, and graphs are made out of points, and you wanted to plot points to represent what's happening here, the interest would play the role it would play the role of the X value, and the final amount would play the role of the Y value. Then by the time you get up to the second year, you have to put how much total interest. This would play the role of the X value. This would play the role. If you're going to plot it as a graph, then you got to accumulate these 50s. Then by the time you get to the third year, it would be 150 total in interest, 50, 50, 50. And then you'd be at 1150 and so forth. And when you go to plot these points on a grid, you move to X and then move to Y, you're going to see that they line up in a linear fashion. And I'll show you a graph of that when I go to give the notes. So that's what happens. The graph is always linear, or in other words, a straight line, when the X value is consistent. In other words, it's a constant increase, 50, 50, 50, all the way down the line. However, when the amount in this first column changes each time, then the graph begins to take on a different shape, which I could tell you right now, in any function or any equation that has a power, also known as an exponent, it takes on an exponential shape. And this is the shape of an exponential graph. Instead of it shooting straight up like it would for simple interest, where it would look like this because the X values or the incremental jumps are always the same on the X, it would look like that. It would shoot up much more quickly, and this is what we call an exponential shape. So that comes up in the notes. Okay, with regard to the calculations for table number 4, let me refresh you on that. First year, second year, third year. And for these, instead of doing this first, you have to go the opposite way. And I was trying to point that out when I taught it the other day, that the formula, the only formula you have for compound interest is this column. See, A for final amount rather than just interest, the way the simple interest formula comes. So here you have to do this and then bring it backwards to get the actual interest amount. Okay, so I'm going to do the final amount first for first year. Just following the formula right here, which is principal times 1 plus the rate, but as a decimal, and then raised to a power time. Now you're going to see, commented about this first time I demonstrated it, that on the first year, the amount of interest that you, the final amount that you end up with, as well as the interest, is the same as in the simple interest account. But then on year 2 and for every year after that, it's different than the amounts that you saw in the simple interest table, which was $50 every year. So that's when they part ways. Okay, so this ends up being, you can put that in your calculator, 1,050. And then if you were going to try and figure out the interest associated with first year, you would just go the amount, the final amount in the account, take out what you had originally called the principal. So A is for final amount, which includes principal plus interest. And if you take out the amount you walked into the bank with, you see that you get $50. Kind of ran out of real estate here. So see, and that was the same amount you had in the simple interest account. Moving on to year 2. Oops, I'm labeling these wrong. Moving on to year 2. Oh, you can't see what I'm doing. Okay. Let's see, share camera. Yeah, just give me a shout out whenever something, you can't see something. Okay, so doing problem number 4 on page 48. So I just did first year compound interest, and now I'm doing second year compound interest, so that's going to be 1,000. This 1 plus 0.05 doesn't change. The only thing that does change is the power. and then you go ahead and use your power key to put that in the calculator. Now my calculator does order of operations. I believe a TI-30 does also. So you can actually press this in just like this, but you have to know where you know what key creates a power. So if I was going to put this in, I'll go one, let me clear this out, 1,000. See if I can move that down where you can see it. And then you can use a parenthesis. The parentheses are real obvious on a TI-30. And then you're either going to have this symbol right here. My symbol is a little caret key like that, a little upward arrow. On the TI-30, the key either looks like this or it looks like this. So right at this point, I'm going to press the caret key for my to create a power. You would press this instead, or maybe you have this on your calculator. So I'm going to go raise it up, put the power on it. It does not mean times 2. It's raised up to a power 2, which is something different. So see, already on year 2, the final amount in the account is slightly different. It's different by $2.50 because in the simple interest account, the table that I just did above this, you only had $1,100, not the extra $2.50. As you get further and further out in time, the amounts begin to separate more drastically. So right here, this would be 1,102.50, and then take it backwards to figure out the interest. So if you want to figure out the interest now this is where it gets a little bit tricky. When I wanted to figure out the interest for the first year, the only thing I could subtract from the amount that I had achieved as a final amount was the amount that I started with. However, now, if you want to know what the difference is in the interest amount, all you have to do now is start using this number and the one above it. So you could go $1,102 minus what you had at the end of last year. And that would give you, let's see, I need to move this down a little bit. Give myself some more space. That would give you $52.50. Just put that in your calculator, 1,102 minus 1,050 that you had last year. See, if you want to figure out the interest, you always use, when you're doing the compound interest problems, the amount you're on minus what you had the last year, and that'll tell you how much brand new additional interest you've earned. However, when you're on the first year, you don't have a number that's above it, so you have to subtract the original amount. So students get a little bit confused with that. Okay, that's second year. Then for third year, okay, we're going to start over here again. It would just be 1,000 times 1.05. This time you're raising it up to the third power. Okay, so 1,000 times, and you can use a times, or you can use the little, if you want to, you can use the parentheses. Either one will get you the same answer. Raised up to third. So now I'm at 1,157.63. Don't give 0.625 because dollars and cents only go out to the second decimal place, the hundredths place after the decimal. So 1,157.63. So if you want to know how much brand new interest have you earned in going from year 2 to year 3, what you could do is say, okay, where am I at right now as far as how much is in my account? I could subtract where I was at the end of the second year, and that'll be how much brand interest the bank has paid me. Because the only way your account, you're not adding anything to this account, but the bank is adding something to this account. So the only way it can go up, which is called interest, is finding out the difference between what you had last year and this year. So 157 minus 1102 and 50 cents. And that turns out to be $55.13. Anyway, just a little recap of simple and compound interest. That was page 48. Any questions about that? Okay, so now you have a couple of different demonstrations of that. Now let's move to page 60. Page 60 is in section 1.5 if you're using the ebook, and we're going to do number 2. I wanted to look at number 2 just because one of your portfolios is on this. This is called a scatter plot. It is not a straight line, obviously, and scatter plots can be given where the dots, the scattered out dots are actually connected, or you can give a scatter plot where they're not connected by a line. And that is what you're actually doing in the portfolio for section 1.5. Dr. Wyatt, who made the videos for those portfolios, has made it very easy because in the templates, we already have the numbers there for you, and all you have to do is highlight them and push graph. So I'll demonstrate that for you after I talk about this. One of the popular type of questions that is asked with respect to a scatter diagram is, where is the diagram increasing and where is it decreasing? So first of all, you have to know how to look at a graph. No matter what kind of graph you are analyzing in mathematics, you're always going to look at the graph, scan the graph from left to right. You're going to look at it going this way. That being said, if I was to look at this graph and someone was to ask me, name the portions of the graph where the values are decreasing, they're talking about where are the y values decreasing. But when you tell them in between what values is that decrease occurring. So first of all, you're looking at this, and one way to think about this is you pretend like you're on a roller coaster. When you're coming down the roller coaster, that means the y values are dropping. It was at almost at 8 right here, then they're going down, 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 down. But when you talk about this decreasing portion, as you would perhaps on a test if they were to ask you this. I mean, even in a algebra class, they like you to be able to talk about such things. So if you were going to say, where are the decreasing portions? When you get into more upper level mathematics, instead of the word portions, they'll call them intervals. Where are the decreasing intervals? So from here to here, you're dropping. So when you talk about those intervals or those portions, you want to associate this dropping portion, this decreasing portion, with the x values that it's associated with. So you got to get your eyeballs to look at this endpoint and this endpoint. Drop your eyes down to the x-axis and name the year that it goes with. So the drop started in 1992 and went all the way to 2000, that looks like. Okay, then you can continue looking. And I guess we could do the increasing portions at the same time. You can just keep moving to the right on the graph. So like for instance, once you get to 2000, it starts to increase. Notice you're going up, up, up. And even this part that looks almost like it's flat, that's even an increase because this point is lower than the one right next to it. So even that is an increase. So you're increasing all the way until you get to this point and then you start dropping again. Okay, so let's talk about this increasing portion right here. Starts at 2000, ends at approximately, looks like about 2003. Whoops, goes over here. So that's an increasing portion. Okay, then we start to drop again. So that drop begins in 2003 and ends at approximately what appears to be about, I'm going to call that 2007, 2003 to 2007. If you want the exact years, instead of estimating what this is, you can look on the previous page where these values are listed as individual numbers. So from 2003 all the way to approximately 2007, the values on the graph were falling, or what we call decreasing. Now we begin to increase again, all the way up to, okay, that looks to be approximately 2010. So from 2007 to 2010, we're increasing, and then finally this last portion from 2010 to 2015, we are decreasing again. So just a question about increasing and decreasing. Okay, doing the portfolio. These portfolios really shouldn't be taking you any more than about 10 minutes. I mean, I guess I realize maybe it'll take a little longer than that because you do have to watch a video. Those videos are typically 4 to 5 minutes long, and then typically how long it takes you to do the portfolio should be about another 10 minutes. So I'm going to demonstrate for you if I can pull this up. Let me stop sharing my camera. I'm going to try and go in here. I have to pull up another screen because when I go into Alex, hold on for a second, it gets rid of my Blackboard shell. Okay, so back to you guys. Let's see how I can do this. I want to share my screen. I want to do the whole screen. I don't know if this will work, but I'm going to try and demonstrate the portfolio stuff for you. I'm going into the templates, as you can see. Please tell me when you can no longer see what I'm doing. Right now, you should be seeing the Blackboard shell. I just downloaded the template, and now I'm going to open up the portfolio template. Hopefully, you can see that too. Okay, so give me a shout out here. Can you see this portfolio template? No, say it verbally because I can't see the chat box right now.
Yes.
Oh, wow. Okay, good. Yay.
Yeah.
All right. So thank you for the feedback. So I was talking about 1.5. I just wanted to show you how easy it is. And this is nothing more than what is said in the video. So you know that all these little tabs regarding the portfolios that you're doing, and you're only doing 1.2, 1.4, and 1.5 in Unit 1. So what I would do is notice that, I sent an announcement out saying that I had made a single Dropbox for you to turn in all 3 of those portfolios at one time. So you're just going to complete all 3 portfolios, save it somewhere where you're going to find it, which would be maybe on your desktop or whatever is convenient for you. And then you just turn in that template once. It'll have your work for all 3 portfolios. When I go to grade, when I open up your template, because that's what you're going to save and turn in to the Dropbox, I'll just click on each one of these tabs one at a time and check your work. And if you've done what was stated in the video, then it's, an easy way to get points, and you're picking up a couple of little skills in Excel. And then, save that, leave it on your desktop, because when you go to do the portfolios for Unit 2, you can open up this same template, which also contains a tab for 2.1 and 2.4, And you can just continue working in it. Your work from Unit 1 will still be there, but at that point we'll only be concerned with what you're doing in Unit 2. You'll open up 2.1, watch the video, do what it says. Likewise for 2.4, and then turn this template in all over again later down the road when the Unit 2 videos are due. Okay, so demonstration of 1.5. She says in the video that if you want to do a scatter plot, she's already typed in all the data for you. She says put your cursor in the middle of cell A1. Let's put it right there. Hold your finger down and highlight the numbers. In other words, drag it over here while your finger stays pressed down. Highlight all the numbers. Release. Release your hands. Now come up here to what's called the banner. The banner is where all the commands are, but depending on which version of Excel you have, you know, different things can be in different places, but in general, they're pretty easy to find. So she says in the video very clearly, push the insert button because you are going to insert a diagram on this template. So insert. Now look for the scatter plot command. Scatter plots are pretty obvious because they're just a bunch of dots scattered out. Now where on certain updated versions of Excel, there'll be icons for each kind of scatter plot. Here on the version I have, all the diagram making features are right here, and I'm going to say that that looks like a scatter plot. So the first plot that she asked for in the video is just the scatter, the points just scattered out but unconnected. So press that. Boom. There's one of them. Okay, let's drag that up, and then we'll put the other one right here because in the video she then goes on to say, now create a scatter plot where the dots are connected with a line. So now see how these are still highlighted? Click over here in the middle of the page to unclick them. That's like clearing the Excel memory. Now get back in here again, because otherwise it's going to give you the same graph all over again if you don't do what I just did. Get in cell A1 again, keep your finger, press down on your keyboard and highlight the numbers again, release. Come back up here, insert, go back to scatter plot, but this time do one where the dots are scattered but connected. I don't know what it'll give, but I'm going to do this one. There you go. I think what that other one was is that when your when your dots are shaped so that they have sharp pointy edges, you can use the other one. Ours are kind of nice and soft and round, so I used that one. And then you can just, you know, get right here. Oops, I don't know why I can't move that. Not working. You can just move the other one so it's nice. Both of the diagrams are nice and clear. That's it. You're done. And the other two portfolios are even less work. Okay, so now let's go back to, okay, I gave you done, let's see. All right, the next thing that I wanted to do is give you the notes for section 1.5. Okay, 1.5, I'm going to give you a few amples for that, and then, you know, next time I see you, we can spiral back to those same concepts and do a little bit more. All right. All right, so back to the document camera. Let me get over here back in the shell. Share my camera with you. Okay, this is pages 10 and maybe 11. At this page, it might only be one page. Yeah, the page from the lessons note packet and the notes concerning 1.5 only have to do with page 10. What I just do at the beginning of the week is I print the few pages, the 2 or 3 pages that have to do with the lessons notes. So now when you go to do these problems, this is what we call, you know, a coordinate plane because there are x coordinates along the x-axis and there are y coordinates along the y-axis. Now these little individual lines didn't come out very dark, that's why I darkened them in for you. So let me do them over here as well. So bizarre. Can't even see them myself. Yeah, there's one that's right there. So that I made these so long that it kind of ran into it. Okay, and then I'm going to darken these in just so I can plot some points for you. Just wanted to remind you of how to plot points, the name of the quadrants, you know, that sort of stuff. Okay, so like right over here is what you call a pair of coordinates. Every pair of coordinates represents a point. Like if you wanted to write this in point formation, it would be 10, comma, 80, and so forth. You can write any of the points like that. When you're plotting a point in what's called a coordinate plane, a plane is a flat surface, and this coordinate plane shows a picture of an x-axis and a y-axis. So you do your x movement first, although you could plot the y-coordinate first if you want to. It's just you would have to go out to 1080. Now, as you begin to graph these points, you really can't make any moves. Nobody can grade your paper, and the whole graph doesn't make sense unless you decide on what's called a scale. A scale is how the numbering system that you're going to adopt for the x-axis, and then whatever you're going to adopt for the y-axis, because they don't have to be the same. You could be counting in ones this way. You could be counting in hundreds this way. The way you make that decision, which is part of what you're going to do on your first test, is that you're going to look at the numbers that you're being given and see how big do they get, because how big they get and how many grid marks you have to play with here on your x-axis is how you decide on the scale. So with respect to scale here, let me look at my x values. Let's see, they go as low as 10 and as high as 60. Now I'm not going to worry about these negatives, because usually in taking care of, I mean, you can consider them, but these don't go any higher than 60. These just have negatives on them. So I know that I need to have enough grid marks that'll take me all the way through 60. So let me see what I have to work with here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be the last mark right here. So if I want to know what kind of scale to use for the x-axis, I can go, okay, I need to get as high as 60. I have 12 grid marks to play with. That means my scale could be 5. And then you start numbering using the scale. You don't have to put a number on every single little grid mark, because then they're going to smash into each other and your paper is going to, you know, look all confusing. So maybe every other one. Just by labeling the first one, people can tell what your scale is, but just to make it convenient for plotting the points, you want to put more than just the first one. This will be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and then that last mark will stand for 60. Likewise, go and put the numbers on the other side. So that'll be -5, that first one, 10, -15, -20, -25, -30, -35, -40, -45, -50, -55. Okay, likewise, make a decision, because I can't grade your paper unless you number things, because then I can't tell if you plotted properly. Next thing, make a decision on your y-axis in the same manner. My numbers, let's see, they go as, and you know, you got to consider the positives and the negatives. I mean, on my positives, I'm going as high as 80. On my negatives, I'm going all the way to 240. That means I need to have numbers, little grid marks that have numbers all the way to 240. And if you're going to go 240 on the negative side, you have to go 240 on the right side as well. So let's do the same thing we did here. Need to go as high as 240. Don't worry about that negative right now. and I have 12 grid marks that are showing. There's 12 grid marks this way, 12 grid marks that way to accomplish that 240. So 240 divided by 12, let's see, 24 divided, that's 20. You can always put it in your calculator. So your scale on your y-axis is going to be 20. So I'm going to label this 20, 40, 60, 80. Every mark counts for 20. 80, this will be 100, 120, 140, 160, 180, 200, 220, and then this top mark will represent 240. Likewise, going down the negative side. Now I can't put a number in there because it's just going to smash into everything. So that'll be negative 20, negative 40. I'll start right here. Negative 60, negative 80, negative 100, negative 120, negative 140, 160, 180, 200, 220, and then right down here will be negative 240. Now plot the points. So we discussed scale. I also want to remind you that each of these quadrants, notice that there's 4 of them, are always numbered the same no matter what math course you're taking. So please know that the quadrants are numbered going counterclockwise. So this is quadrant 1, moving this way counterclockwise. This is called quadrant 2, quadrant 3, and quadrant 4. Plotting the points, I'm going to do the X first. Now that I have something to judge how far I'm moving, in other words, a scale, that are plotted, that are given right here. So I'm going to go to 10 and then up to 80. Get your finger on 10, go up to 80, plot the point, and then label it. Okay, so there is a point in quadrant 1. All points in quadrant 1 have a positive X as well as a positive Y. Next point is negative 20, negative 60. So on my x-axis, I'm going to go to negative 20. And when I get to negative 20, I'm going to drop to negative 60. Line up those numbers, label it. Everything in quadrant 3, which is the quadrant that I'm in, has a negative x and a negative y. Going to the next point, negative x but positive y. That'll put me in this quadrant. So I'm going to negative 40, which will be right here, and then I'm going up to 200. So that'll take me all the way to right there. You can kind of just line this up with this. So that'll go, I don't care if you have these lines, that'll just make it nicer. And that's a point in quadrant 2 where all points are negative on the x, positive on the y. And for this last point, 60, negative 240, that would be over to 60, which would be right here all the way to the end and all the way down to 240. That would be that point right on the edge there. Okay, so just a little reminder about what you know regarding plotting coordinates and developing a scale, an appropriate scale that will allow you to plot the points that you've been given. Okay, this I was talking about earlier. These are the kind of graphs that come from simple interest and compound interest. This is called an exponential graph. That's called a linear graph. Let's fill in these blanks first. When reading a graph, I was pointing out to you earlier that you read it going left to right. That way you can tell where there are increasing portions and decreasing portions, and you can answer many other types of questions that are asked in some courses. Okay, a good graph has a clear scale, ungradable, incomprehensible when it doesn't have one. In the last section, we calculated simple and compound interest. For simple interest, we added the same amount each year. This means that the graph showing simple interest is a linear, meaning it's a straight line, a linear graph. So this would be That picture that you see, that's a straight line, would represent what happened in the simple interest table, the calculations that we got. Same amount of interest each time. Compound interest grows exponentially. And in fact, part of the formula has an exponent. So we see an exponential graph. Exponential graphs always have this shape. They begin looking like they're straight, and all of a sudden they shoot up and they grow much more quickly than this does. In fact, if you allow this graph to continue, it would shoot straight up like that. Not straight up, it'll always have a slight curve on it, but it has that curve shaped in contrast to the way a linear graph looks. Okay, so just a couple of ideas. There's not much in section 1.5. 1.4, you know, is harder because it's got the simple interest in things, but wanted to bring a couple of graphs in here, talk about scale and plotting points. Anybody have any questions? Okay. Right. That takes me to the last leg of the race. Right now, what I'm going to do is, this time you're going to do a class activity rather than it being in Socrative. It's going to be a diagram that you're going to draw. I'll see if I can put some graph paper in a folder for you on your Blackboard shell, but you could just do it on plain paper if you want. I mean, you could also do this. What I do when I want graph paper, I just Google free printable graph paper, and then it'll let you pick certain types of graphing grids. When it's a circle, which is what we're going to be doing, a circle graph, those are called polar graphs. But you know, I'll just try to help you avoid that, but I'm just telling you in general, you can print free graph paper, and I'll try to put some in a folder if I remember. But anyway, I want to demonstrate for you again how to create a circle graph, because this is another type of problem, not a section, that seems to be a sore spot for students on the first test, so I want to review it again. All right, so what do I need to share now? Let me get my head on straight. I wanted to show you first, before I go off into giving my example, where you're going to turn it in. Okay, so share application screen, Chrome tab. I want to show you yeah, that should work. Okay, so now you should be seeing your Blackboard shell again. Might as well, I mean, I'm kind of doing this so that you're prepared and not anxious about turning in work when you have to create a PDF copy. First of all, this is where you're going to turn it in. Notice that down here at the bottom of your Blackboard shell, it says drop boxes for the work that you do during class activities and tests. If you're going to drop box your portfolio assignments, it'll be in the portfolio folder, which is up here. Okay, so drop boxes having to do with portfolios will be in the portfolio folder, trying to make a folder that was one-stop shopping for your portfolios. But when you're doing an end of class activity that has, you know, something like a drawing, then you would put them right in here. You just go tap on that, and right there's the Dropbox. Just look at the title, click on there, says what it's worth, when it's due. I got to change that due date because I had prepared this for last week, but then we never got that far. So the due date will be today. You're going to do it today and turn it in. So when it says write a submission, I would just highlight this right here, the name of the class activity. I would just, you know, Control C and copy it, and then I would press the button that says write submission and dump in that title. Then, of course, you're going to create a diagram. Don't take a picture of it with your phone because that will not attach here. When you go to browse your computer, you need to be able to browse and find a PDF version of whatever work or picture you're turning in this Dropbox. So scanning apps are how you create a picture that turns into a PDF copy. And if you have never used one, you just go to the Play Store on your phone, load up a scanning app. I like Tiny Scanner. Sometimes I use Genius Scan. I think I put that for you right here. I put like a little 4-minute tutorial for those of you that even think you need one. A lot of these apps are kind of self-explanatory, but more than happy to put this little tutorial here for you in case you've never created a PDF. But you know, now that we went online pretty much since March, this is just a super common thing. I'm saying it for those of you that are just coming back to school, or for whatever reasons don't know about scanning apps. And you basically just take a picture and the app turns it into a PDF copy. So if you don't know that, this is a free scanning app, and you can, this is a video of it. You have to get the app. This is just a video of how to use it. You could get the actual app in the Play Store. Okay, so as a demonstration, I'm going to re-demonstrate how to do a circle graph and how to turn it into degrees. When you were in your Socrative activity the other day, I asked straightforward questions like, let's say there was a portion in the circle that had 38%. 38% of the circle was devoted to a particular idea. How many degrees would be equivalent to 38% on a circle? And that was just 0.38 times 360 degrees. That's the degree equivalency of 38% with respect to a circle. So that's what I'm going to be demonstrating, in addition to showing you how to create a circle diagram, a circle graph pie chart as it's called. Okay, so let's see. I am going to do one, if you want to look, on page 10. The one that you're actually going to do, and it says on the Dropbox where you're turning it in, it says do page 38, number 1, and this is the name of the circle, the pie chart. It's called U.S. Energy Consumption by Source. I'm going to do one on page 10. So let me get out of here. So the one I'm doing on page 10. And if you're looking for this information, it's part of section 1.1 if you're looking for it in an ebook. And page 38 will probably be in unit 1 also. Anyway, so here's a circle diagram right here, and you can see that there are various percentages. There's 46% for this section right here, and if you look right over here at what's called the legend, you'll see that this bluish purple color is for Clinton. So when you go to do the diagram, you're going to label Clinton, the percentage, and we're going to rotate and show that we have an understanding of degrees. Then this next section right here, which is kind of reddish orange, that's devoted to Trump, 38% for that, and so on. This next like pea green color is for Johnson, 8%. Next little tiny portion at 2% is for Stein. And this last portion, which is kind of bluish green, is undecided. Here they just made a bar graph of it, but you're doing the circle graph and you're going to create it yourself. So we're going to do the calculations, the degree, to get the degrees, as well as labeling a circle graph. Okay, so here's a clean circle graph. This is page 10. So the first thing you need to do is the calculations. As I pointed out to you, there were various percentages there. First one was 0.46. Right, let me get some paper to lean on. Hold on for a second. I'll be marking up my table. So the first one is, now wait a minute. Can everybody see my camera? Can I get a little verbal on that?
Yes. Yes.
Okay, good.
Yeah.
Thank you. So 0.46 times 360. I'm going to lay out the calculations first and also label the person I'm doing the calculation for. If you put this in your calculator, I believe it comes out to be 165.8. We're going to round off to approximately 166 because putting all those decimals is just going to complicate things more. When you see that they have changed the marks like this, whenever I write this, that means I'm approximating, or in other words, rounding. Okay, then the next person, this one's Clinton, was Trump. And the portion of the circle devoted to him is 38%. But when you're doing percents, using them as part of any calculation, they need to be in decimal form, whether you're doing interest problems, whether you're doing degrees that have to do with circles, you have to convert them into decimal forms. So with respect to Trump, it's 136 point something. You can put that in your calculator. I rounded it off to 137. Next little section on that circle was, I think the next section was, hold on for a second. Next little section going around the circle was the 8% pea green portion, so I'm doing that next. So this is my 8%, always multiplying by 360. Now, if you start using 46 and forgetting to turn it into decimal, you're going to go way over 360. That should be a flag to you that something went wrong. So here you get approximately 29 degrees. Then there are some other people in that circle. There is Stein at 2%. 2% of 360 degrees is approximately 7 degrees. And then the last one is 6%. Let me just check that out again. Yeah, it was the 2% and then the 6%. So the 6% comes out to be approximately 22 degrees. And that's for the portion of the population that was undecided. Okay. Now you start taking this information to the picture. So if you want to write that somewhere, I'm going to move the picture up and start putting it on the diagram. So for Clinton, we're going 166 degrees. So first you want to familiarize yourself with the marks that are on this. If I can make this smaller, I can't, but I can go like this. Hold on for a second. Okay, now you can see more of it. Okay, so if we're going to go to 166 degrees, first let me see what these grid marks are. I think they're 10 each, but 10, 20, 30, 40, 50, 60, 70, 80, 90. Because by the time you are straight out like this horizontally, from here to here has to be 90. So keeping that in mind, that's how I know that these are 10 each. So if I wanted to go to 166 for Clinton, then I would use these to help me judge. Like for instance, from here to here is 90, and here to here is another 180. Okay, again, you can't see what I'm doing. Let me make it even smaller. Okay, so I was saying that from here to here is 90, and then from here to here is another 90 by the time you come straight down here where my pencil point is. So if that's 180, let me back it up to 170, considering that these are increments of 10, 160. So here's 160, here's 170. That's about 165, so 166 would be right in there. And then right from that little notch mark, take it all the way into the center. So you're creating a radius, and that radius digs in to the circle at 166 degrees. Okay, you want to label this portion from here all the way to here is devoted to Clinton. So you can put that right in here inside the circle. And you can even put the percentage, which is always, they always pretty much put that in the diagram. That had to do with the calculation that you did, where you converted it into a decimal. Okay, that 46% of the circle is 166 degrees. Okay, now we get to the next person who was at 38% and needs to have 137 degrees devoted to him, to Trump. So if you want to know where 137 degrees is, it's 137 from where you're at right now. So your next stop is going to be, right now I'm at 166. I'm going to add 137, and that takes me to 303. So I'm going to go all the way to 303. So again, where is 303? Well, to get halfway around the circle, from here to here is 180. This is another 90. Every quarter of the circle is another 90. So by the time you get here, you're 90, another 90, another 90. That would be 270. 90 times 3 is 270. Then 280, 290, 300. So if this is 300 right here and you're going to 303, just go a hair beyond it and connect right into the center. That would put you at 303, rotating around this circle. So this whole section from where you stopped for Clinton to where you stopped for Trump is 137 degrees. So you can put that this section's devoted to Trump, and it is 38% of the circle. Okay, moving to the next category, which is an 8% category, meaning 29 degrees should be devoted to Johnson. So if I want to know where my next pit stop is, right now I'm at 303, and I need to move an additional 29 degrees around that circle, which takes me to 332. You can put these in your calculator as you go along. Okay, so now I'm going to 332. So this was already 300, right before the 303, 310, 320, 330, and just a tiny bit beyond it would be an estimation for 332. So go from that little mark all the way into the center that you hit at 332. By the way, when you're rounding off every single number as we have, that's going to make you sometimes hit a true 360. You'll sometimes, go over one, and sometimes you can be under 1 degree. It's never going to be any more than that. And that'll be, if you're doing more rounding up than rounding down, you'll tend to be a degree over. And if you're doing more rounding down than rounding up, then you tend to be like a degree under. Sometimes you'll hit it right on the nose. So we'll just make it up on the last portion. Okay, so this 8% that I just did was devoted to Johnson. So put his name in there and put in the percentage that you used when you were doing the calculation, the 0.08. Okay, then next is a 2% tiny portion, which gives us another 7 degrees. So we need to move 7 degrees beyond where we are right now. That takes me to 339. So right before 340. So this was 330. This is 340. Right before 340 would be 339, and take it all the way into the center. Okay, and then you got to kind of squeeze his name right in there. I'm going to have to turn the paper sideways just for a second. That'll be Stein, coming in at 2% of the vote. Okay, that's that portion. And then there's only one portion left. So even if you do go a degree over, you're going to stop it at 360. Okay, so let's see. The next one is that extra 22 degrees. That didn't come out very good. Doesn't even look like a 22. So an extra 2 degrees. That actually takes you to 361, but we're not going to go over 360. That extra 1 degree is just because of the round. Okay, so then you're coming right here. You're going to stop right here. Takes you right back to 360. And then put that in there. This section is undecided at 6%. Okay, the undecided section came from this 0.06. Okay, you will be doing a problem just like this. Just wanted to give you another demonstration in addition to the one I gave last week so that it could refresh your memory. Okay, you'll be doing the one on page 38. Just look at Dropbox. The title of it is right there. Okay, everybody have a beautiful day. I'm going to have office hours later today. I will send out an announcement of that. My office hours are going to be from 12:30. Actually, no, sorry. They are actually from 11 to 12:15, but that's a trigonometry Q&A session. And then I have some other office hours, 12:30 to 1:40. Anyway, I'll send out an announcement and a link that you can use to join in Blackboard Collaborate. Have a beautiful day, and I will see you next time. See you on Thursday.